So this is my first time in Codemotion. I must say I'm very excited. This is probably the only conference where I know they're providing Red Bull. That's pretty cool, right? That also means that you guys cannot doze off. You have to listen to me. Okay? So we are all caffeinated here. I was worried about this title actually because I didn't know whether this title will make any sense to people here. But I'm going to do a little bit of polling just to assess where am I right now here. Is that how many of you have heard about Akka before? Okay, you guys can leave then because this is all about introducing Akka. What about reactive programming? All right, pretty cool. Okay. Please ask me lots of questions. I want to make it really interactive. And when I get excited, I try to speak really fast. If I do that, stop me. Say, hey, you're going way too fast, okay? I'm here. And you guys are driving this presentation, okay? So you tell me where to stop. You tell me, talk about this, talk about that. We can do this. All right. So a little bit about me. So I am actually a Scala developer. So some of the stuff we're going to do here in Scala, is that okay? If Scala syntax, I will keep it on very minimum level. If there is some confusion about Scala, please ask me questions. I will be happy to explain. I'm not sure why my slides are cutting off there. That's interesting. Okay, so I have a book out there. That's probably the hardest thing I ever done in my life. I'm never going to do it again. I'm going on camera saying I will not write book again. But that was the one that I want to talk about. I work for a company called TypeSafe. How many of you know what TypeSafe is? Do you know how we make money? See the problem? So we are in a business of helping people building a reactive application. We want to be the best platform in reactive. Okay? So we're going to talk a little bit about how we do that. We work with our customers, help them to build reactive application, and we'll talk about why it's important. But before we do that, I want to throw some definitions out there so that we get it out of the way, and then we'll talk about why we should care about this thing. Okay? So what is Akka? Akka is not a framework. Okay? We call it a toolkit. It's a toolkit for building distributed, fault-tolerant, message-driven application. I mean, I tried my best to put all the buzzwords there, okay? And through the next hour or so, we're going to go through all of these words and kind of understand what it means. So Akka provides what? Akka is a toolkit. It provides all of this. So it provides concurrency, distribution, resilience by design. Okay, resilience by design, elastic, decentralization, high performance, everything you could think of. Okay? But why? I mean, why learn another framework? I mean, we are already stuffed with so many tools out there. I mean, I have to learn about new caching techniques. There are NoSQL databases coming up every other day. Not to mention there is JavaScript frameworks coming every hour. So why should we care about this? It turns out, while we were busy doing Java, Spring-based applications and things like that, hardware vendors had different plans. They're changing the world for us. So the rules of the game actually have changed without even telling us. They've been doing this for a while. How? So if you look at the applications that we used to designing for 60s and 90s versus what we have right now. Okay, we used to have single machines. Remember those days, one node, you just pick a jar file or whatever, deploy it there, you are done. You are in production. I don't know how to fix it. Maybe, yeah. But what we have today is a cluster of machines, right? Everybody's talking about EC2, and there are hundreds of nodes they go through and deploy. We used to have single cores. Now we have multiple cores. RAM used to be expensive, right? Nowadays we're talking about cheap RAM. We are getting machines with 32 gig RAM, 64 gig RAM is going to be reality in a year or so. Disk used to be very expensive, nowadays it's very cheap, okay? Networks used to be slow, and we are getting a fast networks these days. Few concurrent users, right? And your application had been considered successful if you have 1,000 users accessing. Nowadays, we are talking about lots of concurrent users. Not to mention this whole Internet of Things comes into the picture. We're going to have millions of connections coming into your application, right? So all these things that we are seeing the changes for us as a developer, this means we need to completely think differently about designing our application. This is where this reactive comes into the picture. This reactive comes into the picture, okay? So reactive programming, can I drop this? Is that okay? Let's try it without this. Is it okay now? Can you guys hear me? So reactive programming, should I talk about this or move on? Because you guys seem to have lots of people. Who wants to hear about this code threads in details? Only one guy. Maybe we can have coffee after this. Two guys, all right. So I'll quickly go through this. So what it turns out, with all these changes happening in hardware, we went ahead and looked into some companies like Twitters and Googles of the world and said, hey, can you show us how you're designing your application? Because you seem to be handling all this problem pretty well, right? So if you look at all this design, there are 4 interesting characteristics that comes out of it. And what Reactive Manifesto is trying to do is just define a nomenclature. It's like a design pattern. You know the importance of design pattern? So that we all use same words, so that we understand each other. Okay? We found out these 4 important characteristics. The first one is, we'll do without this. The first one is responsiveness. What responsiveness means? Okay. The people who raise their hand, they know reactive. What's responsive?
Response to users.
Response to users. Is that important? Probably the most important thing, right? If my application is not responsive to the user, I'm losing money. I'd rather shut down my business, right? So remember, the essence of reactive trait, reactive manifesto is, how can I go and build a responsive application? To build a responsive application, we learned that there is 3 important pillars that we have to consider. Okay? It's always better to come from the top, actually. Okay? First pillar is on the left-hand side. It's called elastic. Okay? Another way to think about it is scalability. Okay? For an example, there is a company called Guild.com. Who knows that? It's a New York-based company. They are in e-commerce. Every day for that company, from 12 to 1, the traffic spike goes up. Every day, 12 to 1. Why? Because that's the time they run their deals. Okay? The interesting characteristic of this is that for that company, for that period of an hour, they need probably hundreds of node drivers to support all the users. But other time of the day, 10 nodes are fine. So that means we need to design applications which can consider this characteristic. It can scale, like an elastic, right? It can scale up and also scale down on demand. That's a very important characteristic we need to have, right? On the right-hand side, the important character is resilient. What does resilient mean? Why is it important? Right, so resilience is about talking about failure. That means if you are running an application, this kind of application, the applications we are building these days, right, where people are in a mobile phone, they want milliseconds of response time, they want your application to be up and running all the time, right? If your application goes down, that means as a business you're losing money. So how can we build applications that could be resilient, that could tolerate failures? Failures like node going down, network partitions, it happens all the time. Right? How can I have an application that can handle that kind of failures? And it turns out all of this that we're talking about is dependent on if we from the code ground up design our application message-driven. Has anyone worked with the message-driven applications before? Before Akka. Any sorts of, on any language. Yeah, what did you use? Anybody? Shout out. RabbitMQ.
ActiveMQ, 0.
Those are all JMS based.
These are queues, message queues.
Erlang, okay. That sounds way too pricey. Okay, all right. So message-driven. Remember, I use message-driven, not event-driven. I know we use interchangeably, but there is a distinct difference. I will buy a beer, whoever can tell me the difference between event-driven versus message-driven. We'll come back to that later. Okay. So it turns out, if I can think about this, these are all my design constraints. If I can design an application thinking all these constraints at the same time, so that I can build my application, make my application responsive, there are lots of interesting things could happen. I could take benefit of all the hardware changes that's happening. I can be profitable, and my applications will be up and running. Okay? So in this presentation, I'm going to show you a way to do it. Okay? So essence of reactive application is responsiveness. Remember, that's what we care about. So I thought the best way to kind of go through this is kind of build this application from scratch. How about that? Okay? So what we're going to try to do is that I had a brilliant startup idea. Let's see whether you guys agree with me. Is that finding cheapest flight. I travel a lot. I mean, this is one of the things I usually do, try to find cheapest flight. So here is my idea. I just stretched it out in whiteboard. We can actually use a whiteboard also if we have to. So what will happen is the idea is very simple. Someone will come in and search for a flight. And this blob here will be my IP. This is where I'm going to build some logic. This is my application. What it's going to do is that we're going to talk to some set of providers. I don't know, Expedia.com, Booking.com, whatever. Okay? And get all the deals. So let's say I'm going from Berlin to London, and find all the offers they have, and can figure out which one is cheapest and return it back. Sounds good? Okay. So I have this idea, and I read about this reactive manifesto, which sounds pretty interesting. I want to use those reactive manifesto ideas to build this application. Okay. So first thing it talks about is message-driven. Okay. We will learn about message-driven. So why message-driven is important? What message-driven gives us that will make my application suddenly reactive and scalable? What is that property? What is that design characteristic? It's right there, right? It says, I should have used some animation there. It says the architect based on loosely coupled design. Why loosely coupled design is important?
Because you don't promote asynchronism. So we can split. We promote asynchronism.
Why split?
It's easier to tolerate failures.
Huh?
It's easier to tolerate failures.
Huh?
You can reach that scale.
It will be scalable. How?
I mean, if it's loosely coupled, okay, you can just make it and pass it around.
So you mean
Compartmentalization. Compartmentalization.
Very good.
You build stateless components. You build stateless components, basically, so that you can scale.
Avoid loss.
Avoid loss. Okay. Any other thoughts?
With a message, you define a contract that permits you to separate the design, who sends the message and who consumes the message. So the architecture is split the two parts.
Okay. And we do that because we want to compartmentalize, right? See, I'm not talking about functional programming, object-oriented programming. Maybe I'm talking about functional programming, I don't know. But I'm talking about a good design practice. Okay? I'm a pragmatic guy. I want to get something done, my work done. Okay? Whatever gets my work done, I will use it. Okay? And I feel like loosely coupled design is a good characteristic. Doesn't matter whether it's Java, use Scala, whatever, right? It allows me to compartmentalize, it allows me to do the separation of sender because it allows me to handle failures better. I'll show you how that's possible. So what Akka provides me to build this? What's this building block? What does that look like? So there are many ways to do that, okay? So let's recap this quickly. So message-driven applications allows me to do loosely coupled architecture, which means I am separating my producer, okay, and consumer, the guy who is doing the work, and another guy who is actually trying to consume the work. Say, hey, update the address for me. Okay, there is some component which updates the address, and this guy. If I separate them out, there are lots of interesting things that could happen. That is, when I send the message, I really don't care who is doing it because I'm not statical. It's not a method call, right? I just send a message to somewhere and say, I don't care when you get it done or when that happens. So first of all, it decouples the design. Second, it also makes it asynchronous. Okay, it's not happening. It's going to happen some point later. Okay, I say update my address, and I go and do something else. Okay, this is probably one of the hardest things that we have to get over. It's not happening right now. It's going to happen some point later. Okay? And another thing, it allows me to do non-blocking. You probably have heard this term many times here. Why non-blocking is important?
Pipelining.
Huh?
You can pipeline.
Why do I do that? To be honest with you, the best, easier code, synchronous code is very easier to understand. I call a mentor, I get the, update the address, I get the new updated address, I'm happy. Now what I'm telling you now is that I will send update address, that's going to happen some point later, I have to figure out where it's going to happen, it's confusing.
Yeah, but in not pipelining these days, you can have, if it's a synchronous, you can have a problem.
Yeah, but what's the benefit?
Responsive.
Yes. How?
Being able to work and present my user with some kind of partial result.
But if an address update takes 10 milliseconds, it's going to take 10 milliseconds, even if I do it synchronously. I don't know how I'm setting time there. It's not actually.
No idle time.
Huh?
No idle time.
No idle time. Okay, go on. What does that mean?
Responsiveness. I can show something else meanwhile.
What non-blocking gives me is effective uses of resource. So for an example, let's say I call this update address method, which does something. I don't know. It takes me 10 milliseconds. If I do it in synchronous mode, what's happening? The thread that's calling that method is doing nothing. Twiddling its thumb. It's just waiting. Okay? Why I care about that? I care about because thread, this is a limited resource for me. For a given machine, for a given hardware, it's a limited resource. Okay? When we're talking about being a scalable application, when we talk about I want to handle millions of requests out there, those are the resources I want to use effectively. Because they are limited, really. There's not unlimited for me. So I want to make sure I don't wait so that I can use that resource to do something else. Maybe update someone else's address, or do something else. Okay? That's why non-blocking is important. All this property seems to be coming out of message. That's cool, right? So how this looks like? There are many ways to do this. But Akka selected a model called actor programming model. Okay, JMS could be another example of doing this. Somebody said active entity. Well, that's another example. But we're going to talk about what Akka uses here, called actor model. And I personally think it's a very interesting model. It's not an invention. It's not something we came up with. It was there from what's the paper came out? 1978, the first paper, 71. It's actually been popularized by a programming language called Erlang. Excellent language. Excellent. So what's essentially Jonas Bonnier and a bunch of guys did is they took that idea, sounds very interesting, and put it in a JVM model for us. So all the stuff that I'm showing you here is possible with literally any JVM language out there. Okay? So what is an actor programming model? Ask me questions, okay? I'm going to build on this idea. Okay. So active programming model, what is this? It's a computational model. Okay, computation is important for us because that's what we do, right? We're doing work. But what kind of model is this? This actually have three important properties. Processing, which is your behavior, method called update address is the processing, okay? What's the next thing? Storage, okay? So storage means, okay, I'm updating my address, but I'm keeping count of how many updates I've done. State. Storage is my state, okay? And communication, and this is where, so far, what I talked about, processing and storage, this is exactly what traditional O is all about. Data and behavior goes together, that's your objects, right? What communication, this is where we can have little bit diverts a little bit here, because in communication, active programming model talks about it's going to be completely asynchronous. Okay, it's not going to be a method call. It's going to be completely message driven. Okay, so one way to idealize initially, it's okay to think about active programming model as just your plain old objects with behavior and state. But instead of making method calls, we will start sending messages. So far, so good? So when we have this computational model, there are three interesting axioms that comes out of it. That means when I send a message, what can actor do? This is part of the paper. When he described this actor model, that I can create a new one, which is very interesting for me. That means if I get a work, I can fan work to, I can contract that work out to someone else. Okay? My math videos here. I get a work, I break the work in smaller pieces, I can fan out. I can, hey, do that work for me. I can send messages to actors it knows. That means if I get a message, I'm a person actor, and I want to update my address, I know, hey, that actor knows how to update the address, I'm going to send message to them, which is very important. And third, this is probably, we'll not have time to talk about it because actor model is also evolutionary, it evolves. That means while the application is running, I can change the behavior of the actor. Okay, which is very interesting. So let's look at graphically how this actually works. So actors, like I say, is an object, but only difference is it doesn't have any API. Actors are like black box. That means if there is an actor, I cannot go into guts of that actor and look, oh, there is that method, I want to invoke it. No, not possible. Instead, the way you can work with actors is that every actor comes with a mailbox as your message queue. Okay? If this is my actor and this is my update address actor, only way I can make that actor do something for me or react to something for me is by sending message to it. Okay, that message will be update the address with all the new details. Okay? I have no control over when this message will get processed, by the way, no control. Okay? I'm assuming some time that message will get processed and I can get a reply back. Any question? So actors is an transaction over threads. That means when we work with an actors, we'll never see these guys here. Never. So behind the scene, if you wonder who is doing this, who is taking the message, putting in some mailbox, or taking the message out of mailbox, is something called this execution context, which is a glorified thread. What we did, we took the limited resources, threads are limited, reusing it effectively by something which is much cheaper. By default in Akka, the size of an actor is 300 to 400 bytes. That means in my this 11-inch MacBook here, I can create millions of them. Pretty awesome. Right? All right, so I'm gonna try to do some live coding. I'm scared. Let's see. I'm actually I'm probably going to run out of time, but we'll see. Okay, so I think it's going to be helpful if we look at this a little bit from the code perspective. Is this readable at all? Where are you sitting in the front? How about now? Okay, so what I have here is that so line number 16 there is a REST. Line number 20 is my REST endpoint. Okay, I'm a startup. I'm building a service where someone will call my find cheapest flight with some information right here. And I'm essentially taking that information out in an object called find trip, and this is where all the work happens. I take the price together. That means I'm going to say I want to go from Berlin to London. This is my start date, and this is my end date. Go. Okay? And this go is nothing but search. Is that cool? Okay. What we're trying to do is spend most of the time inside this method. So we're going to go there. and see how actors looks in real life. So obviously this thing out here is the message. So this is my criteria from city, Berlin to London, tomorrow and coming back on Monday, let's say. Okay, that's a criteria I got. The first thing we have to do is that obviously I write that actor model. I want to implement everything in actor. So how do someone create an actor? Okay, first thing you have to remember, when you create an actor, actors need some sort of resources. Remember the treadmill thing? Remember that box there? So all this machinery, the engine behind actors needs to be created. This is abstracted in something called actor system. So one way to think about it is an actors doesn't come alone, they come in a system. Okay? Because actors always shine when you have a group of them. So first thing I'm going to do is that I'm going to create an actor system. This is Scala code, but we're not scared about it, are we? No, yes, we should not be. Okay, so I have a system. Okay, that means by this time those thread pools and all the machinery has been created for me. Now I want to create an actor. Let's call that actor, naming is one of the hardest things, isn't it? Let's call it search, flight search. So I'm going to say system, hey system, go ahead and create an actor for me using a method called actor of. Okay? Actor of takes something called properties. The way you should think about properties is nothing but a factory. Okay, I would love to create an actor for you, but can you give me a factory? There's some method, some mechanism in which I can create an instance of that actor. So let's say we're going to define that in a method called props here. And we're going to name this actor a search flight. All right, so I'm going to go in here. I'm going to create a new file here. I'm going to just show you one example. I think that will be helpful. Search flight. Search flight will be an actor. To create an actor, first thing you have to do here is extend an interface called an actor. Okay? The moment you do that, it's going to ask you to override, implement an abstract method called receive. What is this receive? Receive is my event handler. Remember that graphic I was talking about message wins to a mailbox? Some point, some thread from the pool will pick up the message. I have nothing to do. Let me check whether this actor has some messages. It's going to pick up the message. They need to send that message to the actor, right? How? By invoking the receive. Receive is my event handler. Okay? So I'm saying, this actor, I'm expecting a message called find trip. Okay? Find trip takes what? Find trip takes from to star. Line number 10, can anyone tell me what's going on? What I'm doing there? Pattern matching. Who said that? Oh, you're not allowed to say. Yes, pattern matching. Okay, it's essentially like switch statement, but in Scala, you can use it on any type. So essentially, I'm unpacking that object and going to the guts of it, figuring out all the parameters. Okay. So once I have that, obviously I need to create a factory for this. So I'm going to create an object search flight. Create the props method that I'm trying to invoke there by passing this constructor, invoking this constructor, I mean. Okay? So if I go back to my find cheapest flight, this will work now. So to make this code actually run, that means now I'm taking a message and trying to queue the message to the actor's mailbox. This is how you do it. So I have an actor now. I'm going to say, actor, please do this work for me by invoking this bang method. Okay, this is called fire and forget or called tail. Okay, using this, I will send this message. What line number 29 is doing is taking the message, queuing into actor's mailbox. Any question? If you don't ask me questions, I'll start asking questions.
What about the result? Because we're sending a message.
Oh, maybe the reply.
Yeah.
So that line is what is doing. So let's imagine what's going to happen. I think it's very important we understand the threading model here. If I do +1 here, what's going to happen? Let's say T1, thread T1 comes in, invokes this method, executes this line number 21, 29. That means it's going to take the message, queues into the actor mailbox, comes back immediately. Immediately and executes the line number 30. Okay, that's exactly what's happening. Okay, this is what I was talking about non-blocking, benefit of non-blocking. I'm not waiting. I'm not blocked for anything. I'm ready for another work. That's important. That's exactly what's happening. Since sending message is so important in Akka, we created a method with one character. Really, that's the reason why we have a bank there. That's the name of the method, by the way. In Scala, you can use symbols to name methods. Or the other alias of that method is essentially called something called tail. I'm saying tail, hey, get this message. Send stuff. Send. We're good? Okay. Now let's look at this actor because that's where the interesting thing is going to happen. I have a design question here. I'm confused. Okay, I get this message, right? I want to be really scalable here. I want to build a scalable app. I have from and to, start and end. So that means I'm looking for a flight, going from and to from back, return to, right? Wouldn't it be awesome doing that search in parallel? Right? It's going to scale totally, right? I mean, I'm assuming I'm reading the hardware changes right. Most likely I'm running on a machine which has multiple cores. 32, 64 is getting common this, 64 cores. Okay? So I have lots of cores. That means running in parallel is going to optimize, improve my latency. Am I right? So let's look at what Akka provides here in terms of scalability. I'm going to switch here a little bit. I'm being terrible with time, by the way. I don't think I'll be able to finish it. But who cares? I'm not going to let the next presenter read. Okay, so I want to be elastic here. So what elastic means? That means scalability, right? Embracing the cloud. This is exactly what the trend is happening, right? I'm gonna request more resources when I need it, or let go of the resources when I don't need it because it's going to reduce my cost, right? So how can I use this? So what I'm thinking is like this, okay? So when it comes to my search flag, this is the actor we just created here. What I'm thinking is that initially I'm thinking I'm going to start in 3 countries here: US, UK, and Germany. Okay. Obviously, when I start with the 3 different countries, each country is going to have its own separate set of providers. Kind of makes sense, isn't it? Right? So when you're searching for a flight, depending upon where I'm going to use that country specific. So for an example, if I'm going from Berlin to London, the from to I will send to this guy, and from the back I'll send to this guy. So that's how I'm going to do parallel. Okay? And turns out, because when I started doing this business, each of this block here could have its own custom deals. If you're going to Berlin, there will be some specific deals here. Or if you're going to London, there will be other deals here. Real worldish, right? This is exactly. I actually have solved similar kind of problems in real world. That's why I took this example. Okay? So what is there, what I can use in Akka, which can allow me to do this fanning out? Okay? It turns out, Akka has something called, okay, so first of all, I need to fan out. What's the second thing I need to work here? What the second requirement, what the second constraint I have here? The second constraint is, if somebody is going to Germany, then I can only forward the request to this guy, not to anybody else. Why? Because I want to do that kind of smart routing, because I might have something cached here. It was in the JD presentation in the morning. That was an excellent presentation, by the way. about talking about caches, hot caches, and then using, because some of these deals that I'm going to have here are going to be cached, right? I cannot go to database and pick it up. So I need to make sure when I route my messages, all the messages that relate to Germany go to this guy. So there are a couple of things. I need to scale out, and I need to do, what is that word? Consistent hashing, right? Some sort of mechanism way I can route my messages. So that messages that going to Germany always goes to that guy. I'm pretty sure I lost most of you guys here. So what can I do here? It turns out Akka has a concept of pool, router, okay, which can route to multiple instances of an actor. So let's understand the trading model here, okay? So if I have a bar here which is mutable, okay, and every time I get a message, if I increment the counter here, do anyone see a problem? I have a mutable state. Is something wrong with mutable states? What is wrong with mutable state?
All.
What?
All is wrong.
All is wrong. Can you tell me one of those all?
Mutable state.
It's so easy to read. I have a count. I'm just incrementing count with one. I mean, what could be wrong here? Thread safety. So the problem with mutable state is thread safety. That means, what if two thread comes in and try to increment the count? They cannot. Right? So if you deal with if you're writing multi-threaded code, have anyone wrote a multi-threaded code before? And you think your code works? How many of you think your code works? So one of the problems with multi-threading is not the thread store. I mean, I can wipe out with threads in 2 minutes. The problem is when you have to deal with mutable state. The reason the problem with mutable state is when you have a mutable state, you need coordination. Somebody needs to coordinate, make sure that it's only one thread is updating at a time. Okay? But I safely did mutation here because one of the benefits of actor is actor execution is always single threaded. So given point of time, only one thread can execute line number 20. Actor system guarantees that. Trust me, it's an amazing guarantee to have. Amazing. In a distributed system, you're getting a guarantee that some code is single-threaded execution is amazing guarantee to have. That means actor is providing a safety to work with mutable state. Okay?
But how can you guarantee? So you have some locks, and it's the same as locking, no?
No. Sorry, we have to take it offline to go into details. Yes?
So you're saying that no two search find actors that will never run together at the same time?
Yes, that's why I'm building the case why I need a router. Now, for a given instance, if let's say the search fly actor, I only have a one instance in my system, that means this is essentially single thread. The way you achieve parallelism in Akka, you create multiple instances. If I create multiple instances of search flight, then if I have multiple cores, in theory, I can run them in parallel. Everyone will have its own count. Okay?
So it's not a shared resource.
No. Okay. So it's not shared resource. Okay. So I want to. That means to parallelize to my search, I need to create multiple instances of an actor because that's the only way I can do it, right? But the problem with multiple instances of an actor is then someone needs to be responsible of routing those messages to the instance. Okay? That's why Akka created something called router. Okay, I'm going to create a pool version. The pool version is that, I will say, this is my router. What kind of router I'm creating? I'm going to create a router. So I'm going to say context or actor of, similar idea. But this time I'm going to create a router of consistent hashing pool. Okay? It's going to say, hey, how many instances of how many routes, if this is a router, how many routes you want to create? Since I have 3 countries, I would say, hey, number of instances is going to be 3. That means it's going to create 3 instances of an actor. So that means if I have 3 codes available, all these 3 codes will be occupied by this actor, so which is good. And I'm going to say, hey, by the way, the hashing mechanism, the way I want you to hash is by country code. So every time a message comes into this router will call this my method, say, how should I route this message? You tell me. It's going to invoke my hashing logic. Okay? Once I have the hashing logic, then I would say props create my search worker actors using its factory method, and I'm going to name this iRoute. That's the only line I need to actually parallelism in Akka, by the way, provided I created the child actor. Okay? Now if I have this router, I know it's not compiling, but I don't have time for this. Now if I have this router, I could do something like this. So whenever you get a message, router forward, let's say search worker find flight from to with this start date and to from with end date. That's it. I take the message, call my router. I just have a parallelism right now. It's going to fan out. Okay, is that easy? Any questions? Huh? Yeah, I'll come back to it.
Okay, yes, a question about the counters. You said that you can...
Line number, please.
Pardon?
Line number. What line?
We define the counter at line 16, and then when you increase it at line 26.
Okay, yeah.
You said that you can have multiple instances of this actor.
Yes.
And my question is, if I have to show to the user the number of searches I have made in the system, how can I, well, how can I get the total number of searches done by the system?
But there's 2 answers. There is no easy answer. The hard answer is it depends what kind of flexibility I have. I mean, so yes, so counting from all that, I mean, there are a couple of, okay, let me give you a couple of options here. Let's walk through this, okay? One option could be I could send a message to this actor which can say, get me count, and it returns count back. You do that to all the actors out there in aggregate. If you're not happy, then I can continue with other options.
Yes, other options.
Yes,
okay.
All right. So I achieved this, okay? Now, so let's go back to the slides because I'm running out of time. We're gonna have this application built by the way. I'm gonna show you some code I have it for as a backend. So far we have implemented this graph actually. Till where? We have implemented till D, UK, and US. We don't have those providers yet. We're gonna do that next. But any questions so far, right? Search classes are using a router which, using hashing mechanism, routes to individual worker joins there. So what I've done so far is this. Exactly, we talked about this already. So let's move on. Move on. Okay. The next one I want to do here is that go back next level down. That means I'm going to focus on the search workers now. What these workers have to do? When you're looking for a flight, what I should do? I will take that message and go to all my providers, say, find a flight for me. To all the providers, that means I need to broadcast the message. Again, I went to Akka documentation. Do you have anything? Turns out Akka has something called broadcast router. Okay? I will give this router will be configured with all the providers. Okay, this could be Expedia and Booking.com, right? What I'm saying is that I'm going to just send a message to the broadcast router, and this in turn will supply that message to everybody else. Okay? So what I have here, I have this message. Search worker has this message called find cheapest flight. And let's look at this code here. So when it comes in, I've created this broadcast group here. we calling it provider proxy. That means every provider, like Expedia.com, for that I have a proxy actor in my system, which knows how to make a call to that. I don't know, REST call, whatever way, right? Some way it knows how to call the provider. So what I'm doing here is that whenever somebody sends me a message, hey, find the flight for me, I go to my proxies and say, hey, find flight. And this in turn going to send a message to all the providers I have. It's pretty simple. And this is where the response coming in. I'm doing this tail here, which is like a bang, again, okay? This is the alias. But in this case, I'm saying, hey, I know I'm sending a message, but please reply to this guy, not me. This is a huge benefit of decoupling. Since the sender and receivers are decoupled now, I can flip them whenever I want. I actually changed the sender. By default, sender is me, but I overrode the default saying, hey, reply to this guy. Why? Who can tell me why I'm doing this? I mean, I'm a little crazy. That could be one reason, but any other value.
Maybe because I spent before, then
I need, yes, I need to aggregate, right? I need somebody, let's say I have a 5 provider, all of them going to come back to me saying, hey, this is 200, 250, 210. This guy, this is my aggregator, which will go through all the responses and find the cheapest one. Okay? Now you must be wondering, wait a minute, that means for every message I'm creating a new actor. This is actually recommended because it's so cheap creating an actor. We do that per word basis. For every message I'm going to create a small actor. So right now I have this. What I have, finally I have this. All of this are responding back to my file, cheapest deal finder. And this guy will have access to the real sender and can finally send back to the response. I close the loop. Yes?
How do I deal with errors or exception? I mean,
yes, I'm going to do that next, I promise. Anything else?
Can you go back to the slide back?
A slide back? Yes, absolutely.
Okay, now we're seeing that we are creating a new actor, the cheapest deal finder actor, for every instance of this message, sorry. And so we have the same problem we had before, because the response of the flight, of the price of the flight, can arrive to different instances of actors, and we have to collect all the values to be shown to the user.
Yeah, that's what this sorry. That was this cheapest deal finder is actually doing aggregate. Is doing an aggregate, and I'm passing the sender. If you think about it, the reason I'm doing forward here, not tail, this is another thing I nobody noticed, I didn't talk about it either. That means it's saying, hey, so whenever you send a message, if you remember that the beautiful animation I had where I'm sending a message, Akka does the responsibility. Whenever you send a message, what Akka is doing? Akka is going to take the message, whatever message is, fine trick or whatever, wrap into an envelope. It's an object, it's a type. That envelope will have your message and the sender that sent that message. Okay? When I'm using a forward semantic, what I'm doing is that if I do tail, what will happen? Akka will create another envelope and make me the sender. But when I'm doing forward, what I'm saying is that don't make me the sender. Continue to have the real sender in. So that throughout my process in this diagram here, all the messages are forward. So that when this guy gets it, this guy has access to the real sender, the original one, so that I can reply. Yes?
How you can know that all the messages are back? I mean, if there are 10 providers or 5, how you can...
Yes, let's go to the next topic. I think that everybody's interested about that. So when I looked into this diagram, obviously some guys have spotted it. Wait a minute, these are all happy days scenario, right? In real world, lots of crazy stuff is going to happen here. For an example, for some reason Booking.com is down. Instead of taking 100 milliseconds, it's suddenly not responding, giving me 4 back. Okay? Or I'm trying to make a call and it crashes, it throws an exception. What do we do with that? So next up, we'll talk about is resilience. Now, Akka has an interesting model. This is what hooked me to Akka, by the way. This only thing. Everything else is, okay, nice, but this is probably the key selling point for me to move to Akka. Is let it crash. Akka has this model of let it crash. And now, this is something which hard. Okay, syntax, which is hard, but we need to kind of rethink it. So all this for decades now, we've been doing programming defensive style. What that means? That means is that you've been taught in engineering colleges, schools, you brought your manager, you take lead, whoever is defensive, make sure you check your parameters, make sure you check for all the nouns, make sure it doesn't throw exception. Are we doing that? We do that all the time, right? But what happens in production? So it goes wrong. Still your SMS comes up in the middle of the night, still you have to log in, still you have to bounce your cherry, and all this stuff happens. Now, well, obviously we kind of figured out, so we looked into application designed by Erlang programming language. Remember we talked about Erlang? Erlang is the first language which kind of popularizes actor programming model. Erlang, everything is an actor. Okay. So whenever we have to look for inspiration, we go to Erlang world and talk to the Erlang programmer and see how we deal with these things. Okay. So it turned out, anybody knows a little bit of history. I'm crazy about history especially because we learned so much stuff from the past. So Erlang, the reason they come up with this language is essentially implement telephone switches. Okay? Your server goes down, that's okay. But if I pick up my phone and I cannot make a phone call, I'll be really pissed. Okay? So it turns out having telephone switches up and running all the time is kind of important. Right? So initially they designed this systems using C++, and this used to crash all the time. And they said, okay, this can't be happening. They called the engineering team saying, we need to fix it. We need to have a system that's running all the time. Okay? So Erlang systems have 7 to 9 nines of availability. Has anyone worked in the application with 9 nines of availability? That means, if you do the math, it means Erlang systems typically goes down 31 milliseconds in a year. Okay? When I first heard that, that's an alien technology. I have no idea how they do it. So if you look into Erlang systems, it turns out what they have done. There's no crashes here. What kind of language is this? It turns out Erlang application crashes all the time. Left and right, it's crashing. But it figured out how to recover from it. Okay? Let me give you an example that I took it from Jonas Bonnier. A vending machine. You know, let me think about vending machine. So vending machine, we all love coffee, you're programmers. So you walk in the morning, you want your nice espresso or cappuccino, you put your coins in the coffee machine, and gives you, it says, oh, you get more coins, and finally gets the coffee, and this is when you're having a good day. You get the coffee back, right? And the days where things are not really that well, what happens? You insert a coffee, insert coins, and it says out of coffee bean. Okay, this is what moment is that? So I'm a programmer, I have no idea how this vending machine, so who fills up the coffee, I've never seen that person. I come in, I put my coins in, I get a coffee, but I get this error, I have no idea how to deal with this error. What this reminds me of? All the empty cache boxes we see in Java code bases. Okay? That means we are throwing exception to the wrong people and wrong code bases who has no idea how to deal with this. Okay? So this handling of error kind of becoming important, and we're going to take inspiration from real world here. Okay, this real world scenario. That's wrong. So in the real world scenario, what's going to happen? You insert coins, coffee is out. What should happen? It should send to some other person. I don't know, floor manager. Make a phone call to the company that deals with this. The person, the thing that knows how to fix this problem. Okay? So if you have a system like this, it makes a call, and I don't know, emergency light goes off in your building, and I don't know, something happens, and floor manager runs to you and says, what happened? And he puts some coffee beans in to make you happy. You get your coffee, and okay, that's the system working. Okay, that's the system working. So how can we get this idea and kind of use this design to our application? So we get a request, we send a response back. If there's a validation error, okay, what does that mean? I'm searching for a flight, but I forgot to give date. Oh, then you have all the right to tell me I'm stupid. Okay, all the right. I mean, you throw me an error page and validation error. But if you say you got a null pointer exception for some reason, by the way, never happens in Scala. So imagine this is a Java application. So you get a null pointer exception. If you throw me a null pointer exception as a user, I have no idea what to do with it. I mean, honestly, share your database code or user ID password. Make sure next time you put user ID password in your error message. Anyway, so you should have some sort of supervisor, some component. Okay? So this is very important, okay? If you forget whatever I said in the presentation, remember this. What I'm telling you is failure is going to happen. Let it crash is all about saying embrace the failure. This is a design time decision, by the way. We are at the design time considering, okay, my system going to fail in production. It's going to happen, nobody can stop it. Now let's talk about how we can recover from it. That means failure is a valid state in your application. It's another state in your application. And you have to start recovering. You have to start thinking about recovery. This is a whole new, this is a design time decision. Once your application in production, you can't do this. But so resiliency is a part of design. So in our case, with the provider proxy, I'm taking one example of it. If provider proxy fails, I should be having some sort of provider supervisor who can listen to these errors. And I don't know, see, this is an interesting design opportunities now. Now, if I get an exception, I'm not going crazy running around in the floor now. I could retry the message again. I could blacklist that provider. I could ignore the message. I could restart. There are so many options out there. I actually got an indication I'm running out of time. So, what is this? Is anyone using it? I want to put this slide out there. It turns out a lot of companies kind of believe in this idea. And they're building application with Reactive. These are some of the companies I have. Actually, there is another important reason why I'm in Milan. I spent yesterday some time with a group in Unicredit. There's a person right there. Can you raise your hand? They're building Akka and Scala-based applications. If you guys are interested, you are in Milan, talk to me.